Hello, my dear students. Welcome to botany class. Today we discuss about megasporogenesis. We know already the structure of flower. In the flower, there are four organs are present: calyx, corolla, androecium, gynoecium. If you observe the structure of gynoecium, there are three major parts are present. On the thalamus, the basal swollen part is called ovary. Above the ovary, a long canal-like structure is present, which is called style. The terminal part of the style is called stigma. Inside the ovary, a number of ovules are arranged in a special manner. These ovules are attached to a special structure which is called placenta. Each ovule consists a central mass diploid cells are present. These diploid cells are called nucellus. This nucellus is surrounded by two protective layers. These are called integuments. This nucellus is surrounded by two protective layers. They are called integuments, outer integument and inner integument. At one place, the nucellus is not covered by integuments and give a small pore which is called micropyle. These ovules are attached to the placenta by a stalk-like structure. This structure is called funiculus, where the funiculus and nucellus and integuments are attached. That region is called calagia. In the diploid nucleus, haploid female gametophyte or haploid embryo sac is developed. The embryo sac, generally polygonal type, most of the angiospermic plants have 7-celled 8 nucleate. Out of 7 cells, 3 cells are present towards micropyle side. 3 cells are present towards calagial side, and 1 cell is present middle of the embryo sac or female gametophyte. This is haploid structure. So, in the nucellus, it is diploid. How the haploid female gametophyte or embryo sac is developed, this process is known as megasporogenesis. So, what we learn in megasporogenesis? In the ovule, the diploid nucellus produces the haploid female gametophyte or embryo sac. How it is developed? This process is known as megasporogenesis. So, megasporogenesis refers to the development of megaspores from the megasporocyte or megaspore mother cell. This megaspore mother cell or megasporocyte undergoes to meiosis. Meiosis of the megasporocyte nucleus result in the form of 4 haploid megaspore nuclei. In most taxa, meiosis followed by cytokinesis, resulting in 4 megaspore cells. These megaspores will form embryo sac. So, how they are formed? This is the megasporocyte, which is genetically diploid. Generally, in micropyle side, any one of the nucellus cell act as a megasporocyte or megaspore mother cell. It undergoes to meiosis and form 4 haploid megaspores. 4 haploid megaspores. The total female gametophyte or embryo sac, the structure, egg apparatus, the 3 cells toward the micropyle side, egg synergid cells, and 3 cells towards the callagel side, antipodal cells, and the middle 2 cells contain cell is called secondary nucleus or polar nuclei. This is the final structure of the embryo. This embryo sac is developed from these megaspores. Out of 4, 3 are degenerate, only 1 is functional. This functional megaspore produce this embryo sac. It is called monosporic. Out of 4 megaspores, 2 are degenerate, 2 are functional. If 2 megaspores to form the embryo sac, it is called bisporic embryo sac. These 4 megaspores are functional, no one is degenerate. These 4 megaspores are to form the embryo sac, it is called tetrasporic. So, these megaspore mother cell undergoes to meiosis and form 4 haploid megaspores. How many megaspores are functional? Either single, rest 3 degenerate, the single produce the embryo sac, it is called monosporic. Out of 4, 2 are degenerate, 2 are functional. These 2 functional produce the embryo sac, it is called bisporic. Out of 4, 4 are functional and 4 produce the embryo sac, it is called tetrasporic. So in the megasporogenesis, it is divided into 3 types: monosporic embryo sacs, bisporic embryo sacs, tetrasporic embryo sac. Let us will discuss one by one detailedly. First one is monosporic type of embryo sac. Megasporocyte, which is genetically developed, undergoes to meiosis to form 4 haploid megaspores. Out of 4, only one of them contributes the female gametophyte or embryo sac is called monosporic type. The monosporic type of embryo sacs broadly divided into 2 types. One is polygonum type, second one is enothera type. So first one is polygonum type. It is 8 nucleated monosporic type of embryo sac. Most of the angiospermic families, nearly 81 families, to show this type of embryo sac. It is first discovered by polygonum divaricatum by Strasburger. So this type of embryo sac is known as polygonum. In the polygonum, the development of embryo sac, which side megaspore is functional? Callagel side megaspore is functional. So we see diagrammatically, we can easily understand development of monosporic embryo sac. This is nucellus, the diploid mass of cells. Any one of the cell towards the micropyle side act as a megasporocyte or megasporo mother cell, which is genetically diploid. It undergoes to meiosis and form 4 haploid megaspores. Out of 4 haploid megaspores, micropyle side 3 haploid megaspores are degenerate. Only callagel side megaspore is functional. This single haploid megaspore to form the embryo sac, that is called polygonum type. Which side megaspore mother cell is functional? Callagel side megaspore is functional. Micropyle side 3 haploid megaspores are degenerate. Out of 4, three are degenerate, single functional megaspore is present, that callagel site and will form the embryo sac. This callagel site single functional megaspore undergoes to mitosis and form two nuclei. One is callagel side, another one migrate towards the micropyle side. Now the two haploid nuclei are present. One is micropyle side and another one is callagel side. These two nuclei again undergoes to meiosis and form two haploid nuclei towards the micropyle side, two haploid nuclei towards the callagel side. At these places, these four nuclei again undergoes to mitosis, four haploid nuclei present micropyle side, four haploid nuclei present callagel side. The four haploid nuclei present in micropyle side, they are called micropyle quadrate. The four haploid nuclei present callagel side, callagel quadrate. From the micropyle quadrate, one nucleus migrate toward downwards and reach to the middle of the embryo sac. In callagel quadrate, one nucleus migrates towards the upper side and reach to the middle of the embryo sac or female gametophyte. At this time, three nuclei are present towards the micropyle side, three nuclei present towards the callagel side, and two nuclei present middle of the female gametophyte or embryo sac. The three nuclei towards the micropyle side and cell wall is formed, and the three cells towards the micropyle side, which is called egg apparatus. In the egg apparatus, the middle cell is called egg. Either side of this egg, the two cells are called synergid cells. The callagel sides cell, three nuclei form the cell wall and act as a antipodal cells. The two nuclei which is present in the center region of the female gametophyte embryo sac, these two nuclei are called polar nuclei. If both nuclei are fused, they are called secondary nucleus and the cell wall is formed. This is called polar nucleus cell or secondary nucleus cell. This polygonal type generally 7-celled and 8 nucleated. Out of 7 cells, 3 are towards the micropyle side egg apparatus, 3 cells towards the callagel side called antipodal cells. This is the polygonal type of embryo sac. It is one type of monosporic embryo sac. And second one is Enothera type. It is 4 nucleated monosporic embryo sac. It is generally seen in Onagraceae family. In the development of Enothera, in the ovule, the mass of diploid nucleus cells are present, which is called nucellus. In the nucellus, towards the micropyle side, any one of the diploid nucleus cell act as a megaspore mother cell. This megaspore mother cell undergoes to meiosis and form 4 haploid megaspores. Out of four haploid megaspores, chelagel side three haploid megaspores are degenerate and microphyll side haploid megaspore is functional. The single haploid megaspore undergoes to mitosis and form two nuclei. These two nuclei are present in microphyll site. At this place, these two nuclei again undergoes to mitosis and form four nuclei. These four nuclei present only microphyll site. In the microphyll site quadrant, one nucleus migrates towards the downward and reach to the middle of the embryo sac. The three cells towards the microphyll site to form the cell wall and act as the egg apparatus. The middle cell of the egg apparatus is called egg. Either side of the egg, two synergid cells are present. Only one polar nuclei is present. Second polar nuclei and antipodal cells are absent in Enothera type. So what is the main difference between Polygonum type and Enothera type? Polygonum is 8 nucleated, Enothera is 4 nucleated. Antipodal cells are absent in Enothera type.